Newton's third law. Whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first object. That means that dodgeball guy and his friend Charlie has 60 pounds of mass. And Gus has 200 pounds of mass.
Probably.
Okay. When they run into each other, so they're running. What this law means, what this law says, is that Charlie's going to exert a certain amount of force. He's not going to exert much, right? And Gus exerts this much force, right? But the total force of them combined is what each one feels. So between the two, there is that much force. Okay? They run into each other. Each one pushes back on the other with the same amount of force as the first one pushed back on them. Okay? So the impact, the amount of force between them is the same. Force equals mass times acceleration, right? Okay, so force. This is force, right? Force. This definition tells you that force is the same. The force felt by each one is the same, right? Yes? Now you have, so this is M2A2. Now, you know what M is. M is 60 pounds. And this M is 200 pounds, right? Okay, so we're going back to Ms. Boyd's algebra class. I want to figure out what the acceleration he feels is. So I want to get A by itself over here. So I divide both sides by 60 pounds. So what is 200 divided by 60?
3.333.
Okay. So he feels equals 3.3 A2. So he feels 3.3 times more acceleration than he does. And if your body tries to absorb that much acceleration or that much impact, you're either going to go flying in that direction or your bones are going to break. That really all of Newton's laws are talking about the same thing. They're talking about your mass and how different forces affect it in some way. In this case, momentum is mass times velocity. Okay, momentum is not a force, but it is related to force. Okay, so if you have a certain amount of momentum, that is your mass times your velocity. And remember, acceleration is a change in velocity. So your momentum describes sort of where you start before you get accelerated in one direction or another by a force. If there is no force to accelerate you, your momentum will stay the same. This is just the same description as inertia was. An object at rest tends to stay at rest. An object in motion tends to stay in motion and at the same velocity. So the law of conservation of momentum is just like the law of inertia, which is Newton's first law. Newton's first law. That's why they say when you're moving, say they say you have a moment of inertia, preferably with a marker that writes. This kind of shows you why I'm saying that momentum and inertia are kind of the same thing. Okay, it's your moment of inertia, your momentum. It is your mass times your velocity. That describes your motion, and then a force is required to change that motion. Only three bullets. Yay, only 3 bullets. This is section 12.4. Your homework on 12.4 isn't till after the quiz, and there's a reason for that. I'm not going to quiz you on 12.4. I want you to read the material and do the homework, because eventually you will need it, but in the short term it's not going to be critical. When we get to the point in the year when you need to understand these 3 forces, I will explain them. Notice I've already talked a lot about gravitational force, right? That's because gravity matters to what we're going to be doing in the short term. Nuclear forces, not so much. Electromagnetic forces are going to be critical later on, but not right now. So I'm not going to go into a whole lot of detail on this. I still want you to read them and be kind of familiar with the vocabulary, just so when it comes time, I won't be speaking a totally foreign language. Okay?